Hi, I'm Francesca, founder of a very recent AI safety org, Wiser Human. And before that, I worked in risk management. And today I'm going to draw on some insights from that field to take you through an approach for threat analysis to help you select areas to look at with AI control. So that was me. So the setting which I chose to look at this within is a system whose job it is to risk assess software deployments. So it synthesizes a lot of different data sources, security testing, evals, inputs, and it outputs a recommendation along with a summary. So the first step is to identify hazards. Now, a hazard is a condition or a capability that could lead to harm. And these can be all sorts of different things: the level of autonomy, the interfaces, the capabilities, propensities like scheming. Next, we want to identify harmful impacts. So these are things which hazards can lead to, which have consequences we want to avoid. So you can see some of those on the screen. And the impact domain is like the lens that we would assess this through in terms of measuring it and like setting the tolerance of where we think that's acceptable. So we can come up with scenarios that combine a set of hazards and that lead to a harmful impact that we're trying to avoid. So, in the example I've got, where an AI is manipulating a deployment decision, it's combining things like self awareness, persuasion, access to a human decision maker to expand its power. And then we can set a risk tolerance on that to say, how comfortable are we around this risk happening? So, we've set this one for like less than 1%. Now, what we can do now is actually break that threat down into different steps that need to be true for this harm to actually materialize. And we can take each task or each step and set a likelihood that we think that's going to occur. Now, there's not an exact science to this, but we could base that on something like a capability eval. It could be an empirical experiment or even like an assessment from like an expert. And then by combining these, we get a probability range that we think this threat will actually occur. Now, let's say we want to reduce that threat. The first thing we can do is look at existing safeguards we have. These might come from information security controls, so like mitigations in an OWASP. There might be safeguards that we used on a human based process that we can take and apply, or there might be safeguards that are being used to protect against maybe misuse threats, like classifiers that we could plug in. Now, for our scenario, there's nothing there that's really going to materially reduce the probability. Maybe we could train the people who are looking at the summaries to better identify persuasion, but we've still got a probability of harm that's outside of our tolerance. Which brings us to AI control. So at this point, we can think, what do we need to incorporate in terms of developing a new AI control to catch these summaries? And we can also back calculate how effective we need that to be in order to bring our likelihood that this harm is going to occur to like under 1% or wherever we set that tolerance. So now we have a set of inputs that we can use to actually design a control evaluation that would bring a threat within our tolerance. So as well as looking at control effectiveness, it would make sense to measure something like the false positive rate. So how many harmless summaries are also being diverted? And then precision, which is around, of all of those diverted summaries, what proportion are harmful? And this gives us a set of metrics that we can use to balance the cost of the control protocol. So any degradation to like the system usefulness and operational overheads against the safety benefit. Great. So quick recap. Identify threats by looking at hazards and harmful impacts, combining these into scenarios to set a threat, and assigning that like a risk tolerance level, which could even be linked to something like a policy around like a deployment policy. Then we look, what safeguards have we got that we can apply? And from there, we can identify the key control gaps and get some actual metrics to feed into a control evaluation. Hope that was helpful. Thank you.